Okay, guys, I think we can start today's session. So, today's session we are planning to discuss multiple topics. So, last session we have been discussing about ROS to Gazebo plugins, and today we are planning to discuss about mainly two topics. And if we get time, we will be discussing this chapter we already seen in ROS 1, and that is the same thing that we are seeing this in this chapter as well. It's actually I have copy pasted these topics, but the thing is that when we discuss in ROS 1, we actually discuss with the ROS 2 project called AutoWare. So yes, so we will be seeing the AutoWare project, and the deep learning. I think we already seen the chapter in the mastering session. So today I'm planning to discuss about these two chapters mainly. Okay, so let's start. Okay, so the first topic that we are going to see is how to create plugins in ROS to navigation stack. Okay, so we have seen the navigation stack 2, and we have seen like we can create plugins in order to add new features into the navigation stack 2. Okay, so we are going to see some of the example that we can use to learn how to create a plugin. Okay, so I will say it is somewhat advanced level, and I can't able to like discuss each line of code, but it's about like giving an idea like how to like set up the plugin, how to write the plugin, then build it, and how to like configure it. Okay, so let's start with the navigation 2 plugin. So let me take 1 second. Nav 2. Okay, so if you take the navigation website, you can able to see the plugin tutorials. Okay, plugin tutorials, and this is what we are going to discuss. Okay, and fortunately we have a good tutorial repository, okay, which is navigation 2 tutorial. Okay, but when I build this repository, I found some build issue in ROS 2 Humble. So I found a pull request which is like this repository. This repository actually this guy actually fixed that, and I am actually using this repository to build or get these new packages. Okay, so there are different categories of plugin. Okay, so I hope you know about planner plugin. Basically in navigation stack we have local planner and global planner, that you know, right? So how to write a global planner and local planner. So in this tutorial we are seeing how to write the global planner, and I will say the procedure is almost same as ROS 1. I'm not sure you remember it, but we have a good example, and yeah, so that is one planner, I mean plugin, and second is CourseMap 2D plugin. So you know, like for the local course map and global course map, you can create plugins. Okay, you can create plugins. So there is an example they have given. It's called gradient course map, and we will see how to set up this. First we will be seeing the demo, and then we will be seeing the explanation, and then the controller plugin. So if you want to change the controller, controller is basically like computing the command velocity, I mean not command velocity, computing the velocity commands. So here is a a plugin which is a controller basically. Okay, so let's start with these three first. Okay, and there is a behavior tree plugin as well. It is already there. Let's see, we can see that as well. Okay, behavior tree, I can just go through it, and yeah, so these are the plugin list that we are going to discuss. So first, starting with the planner plugin. Okay, so if you check this tutorial, what this planner plugin do is that if you give a goal position, okay, this planner will be actually creating a straight line from the current robot position to the goal position. You can see the demo from this GIF file. Okay, so what I did was I just configured these planner in this PC to see the to show the demo first, and after that I will be explaining how to set this and how to write it. Okay, so I will say again, like in order to write the plugin, it will be better to refer an example. Okay, so first I'm doing is I am starting the simulation. Okay, and yeah, so simulation of the turtle board, and I'm starting the navigation. Okay, yes, now so the navigation is there. Now in order to do the localization, I'm, instead of starting or doing the MCL, I'm starting the G mapping, not G mapping, the SLAM toolbox. Okay, so yeah, so the robot is here. So now I'm just giving a 2D nav goal. Okay, maybe I can just increase the size. Yeah, yeah, I think this is fine, I guess. So if I'm just giving a goal position, you can find it is planning a straight line. Okay, it is planning a straight line. It is not planning a like a regular plan in the sense there are some curves in it. That looks more natural, but here you can see it is perfectly straight. Okay, and it is not caring about the obstacle as well, so maybe it will be going closer to the obstacle. It is like simply creating a straight line. That is the thing. So always straight line. And yes, so I hope you got the use of this plugin, right? So it will help us to create a straight line global plan for the robot. Okay, so where can we use this? So this can be used in many situations. Like in case of AMR, what we basically need is a straight line, right? Mostly straight line. So if you are working with AMR or I mean those kind of robots, creating a global planner and also the local planner will be helping you to orchestrate the movement. Okay, yes, so that is the demo, and now we can see how the plugin work and how to configure it. Okay, so let's jump into it. So I have shown you the repository. Okay, so this is the official navigation 2 tutorial repository, and the global planner that we have used is this package nav2 straight line planner. Okay, and if you set it up, there is some bugs in it. You can try it, so it will not build. So when I check the pull request, I have seen this repository, which is a fork from the actual repository, and I think this is actually working. Okay, so that's why I mentioned this. And now we can just jump into this package first. Okay, so what I did was I just cloned these list of packages into a workspace. So if you remember, we have a ROS2 control workspace, and I just cloned these packages into this src folder, and you can find the nav2 straight line planner here. Okay, so let's see how the planner plugin looks like. Okay, so if you talk about navigation, I will say the important one is the planner itself. Okay, in case of navigation stack 2, the planner actually matters, then controller and behavior tree. If you want to add some new behavior tree actions, we can use, you can create it. Okay, so yeah, so if you are checking this package, first we can check the package.xml. So it is basically a C++ package, and you can see the dependencies. It's RCL-CPP, then std messages, then nav2 messages, then nav2 core, then the plugin lib. Okay, so this is the major, or like one of the important dependency in this package, which is plugin lib. I'm not sure you heard about plugin lib. In ROS 1 we already discussed about plugin lib. Plugin lib is simply a framework. It's not a framework, it's a library in ROS. And what plugin lib does is that it will be giving us the functions, okay, to create plugins and load it, unload it. Okay, so this plugin lib framework or library is already there with ROS 1. We have seen some examples of plugin lib, and that is actually ported to ROS 2 as well. Okay, so this plugin this plugin is actually created with the help of plugin lib. So this is the main dependency of plugin lib. And how the plugin work is that the details of the plugin should be mentioned in an XML file, okay, which is actually seeing here. So just outside the package, you can see package.xml and cmake.txt, which is helping to build the plugin, and we have the XML file. Okay, so here you can see the description of the plugin, description and the class name. So basically, if you check it, this is a name. I think you can give any name for this, but these are the important thing. Okay, so like the nav2 straight line planner is the namespace, straight line is the class. Okay, and you have to mention the same thing here. Okay, so this is the name and this is the class it is pointing. Okay, and you have to note the base class of this straight line class is nav2 core global planner. Okay, so what we are doing is we are creating a planner called straight line. Okay, we are creating a planner plugin called straight line, and the base class of this planner is global planner. Okay, nav2 core global planner. So this is a very important file that we need to keep. Okay, so that plugin file should be export here. So this export tag is mainly using for plugins. Okay, so if you are creating a package, you can see this export tag, but mostly these tags will be unused mostly. Okay, but these tags are using when we are using or when we are creating a plugin. Okay, yes, so that is the global planner package.xml, and in CMake list what we are doing is we are basically building this plugin. Okay, so yesterday I mentioned that the plugins are building as a library. Okay, so the end product will be a .so file. .so file means shared object. Okay, so we are simply building this plugin CPP file called straight line planner. Okay, we are building, and you can see it is a library. Okay, and it is exporting, like we are mentioning the plugin description file, which is the nav to global planner plugin.xml. Then yeah, I think that's it. Okay, so so this is the basic basic CMake list that you can use to create a planner plugin. Okay, and coming back to the source code, we can see a CPP file here and a header file here. So if you just go through the header file, you can able to see the class definition of the plugin. Okay, class definition, and in the CPP file you can see the class description. Okay, or definition. Sorry, there is a change. In .h file you can see the class declaration, and in the CPP file you can see the class definition. Okay, so here you can see we have a namespace now to straight line. So this namespace should be matching with the XML file that we have mentioned. Okay, and the important part again, we have a class called straight line, and this should be inheriting from the base class. So what was the base class? It is nav to core global planner. Okay, so if you inherit this base class from, if you inherit this base class, then you will get some functions to override. I think when we discuss the gazebo plugin, we also see some functions to override, right? The same thing. Okay, so here you can see we have several functions to override. So these are the functions to override. So one is configure, then clean up, activate, deactivate, and create a plan. Okay, so when you load the plugin in navigation stack, first it will be doing the configure, then you can activate or deactivate anytime. Okay, it is like a lifecycle node, and the important part is create plan. So you can see here this function will be called if you are giving a goal position to the planner. Okay, so basically this function will be receiving the goal position automatically when you the navigation stack will be giving the goal position internally, and this function will be receiving it. So you have to write the algorithm for the global planner or local planner inside the function. Okay, currently we are writing for the global planner. Okay, and other stuff regarding you can write any global planner, right? So it depends on what algorithm. You can write a symbol A star or anything you can write. Okay, so that is what the create plan is the most important function in this plugin. And if you just have a look on to the CPP, which is actually the definition of each function, you can see there is a configure function which is defined, and clean up, then activating. There is nothing inside the activate, there is just printing statement, and the most important function will be the create plan. Okay, so the create plan basically just generating a set of points from the starting to the end to the goal position, like it is just finding the straight line from the starting to end and just creating a set of points and then just return the global path. So global path, if you check it, the global path should be a type of path message. Okay, so we have to note. So this create plan will be returning the global plan. Okay, so whenever navigation stack 2 is calling this function with the goal position, it will be returning the global plan. It's simple actually. So the logic we have to write inside the create plan function. Okay, so it will be returning the global path. So you can do anything here. Okay, so this is a straight line planner, and we have seen the output of this, right? We already seen the output, so I'm not showing it again. So basically, like, it is like moving from A to B straight line, and you can able to find out most of the stuff from this template. Okay, it is working. Now we can see the configuration. Like, we have put the planner in your workspace, okay, and it is building, everything is building. So how we can use this planner on your navigation stack? Okay, so that is one important part. So this thing is already mentioned in the tutorial. Okay, this thing is already mentioned. If you just check it, the tutorial, you will get everything, the details. And if you want to use your planner in the navigation stack, you can simply change this configuration. So I can show you how to do that. So if you are using Turtlebot navigation, which is one of the basic navigation that you can use to learn these learn navigation stack 2 and also working with plugins. So here what I did was, there is a package called Turtlebot 3 navigation 2. Okay, and inside that there is a param folder, and the param folder for burger is burger.yml, and this is the param folder for the navigation stack for burger. Okay, so you can see the big navigation stack 2 parameters, and you can see the parameter for each nodes. Okay, so we are going to change the global planner, right? So just go down, and we have map server. Okay, one second guys, maybe I can search it. Global planner, or simply planner thing. Yeah, so if you check, you can see a tag called planner server. Okay, planner server. So the planner server, I mean, you know what is a planner server, right? Inside the navigation stack 2, we have planner server, control server, behavior server, all these servers exist, and these plugins are fitting inside those servers. Okay, so I hope you understand that. Maybe I can show you that. So like, one second. Yeah, so you have seen the planner server here, right? So the planner server, inside the planner server, you can plug this planner plugin. Okay, like that, in each server, these servers are actually taking these plugins. Okay, so if you check the configuration, the planner server, actually you can mention the plugin name. So here, this is how I have done. So in the planner plugin, there is a field called grid based. Okay, and grid based definition is mentioned here. So earlier it was navfn planner, which is based on A star by default planner in ROS. Okay, so I just commented that, and I just put the planner that we have built in the tutorial. So which is nav2 straight line planner straight line. Okay, and I am just using the grid base. So this is a setup that you have to do for the for working with the straight line planner. Okay, so I hope you understand it, because we simply need to go to the configuration, just mention the plugin, okay, that we have created. Okay, so this is the definition, and this is actually we are mentioning that definition, that definition name, so the navigation stack will be automatically used. Got it? Okay, so now we are going back to the next one, which is the course map. Okay, so I'm sure that you are aware of the course map, right? The local course map, global course map. So the local course map and global course map can be also we can replace using course map plugin. So here you can find a course map plugin, and you can see the similar dependency like plugin lib, nav2, common 2d, all these things. The same structure as the planner. Okay, you can find the XML, and the change is that the base class of the course map plugin is nav2 course map 2d layer. Okay, and the name of our plugin is gradient layer. Okay, and if you check the header file, you can see how the plugin look like. The same structure, namespace, the name of the plugin, the class, main class, and this is inheriting from the layer class. Okay, nav2 course map layer class, and we have some functions to override. The virtual means these all are virtual function which need to be override. So here the main important function is obviously the update cost. Okay, update cost, which will be always updating the course map. Okay, course map basically means the we are providing a static map to the navigation stack, right? And these static map actually been inflated with a layer, and there is a layer around the robot for the local course map, and global course map is actually using the main map. Okay, the complete map. So here we have seen the header file, and now you can able to find the definition of this plugin. So again, the same thing, we are seeing the definition of it, the on initialize, update bounds, then these all are the override, and the update cost. This is what the important function which is actually updating the course map. Okay, and at the end you can see this is how the plugin lib code works. Like you can see plugin lib export class, the name of the class, name of the plugin class, and the base class, which is layer. So you can see that in the planner code as well. So these plugins are keeping the same pattern. Maybe I can show you how to use that course map plugin. So you can see here, one second. So here we have, so in navigation stack you have global course map and local course map, right? So you can configure the global course map and local course map. So what we are doing is, this is the value, or this is the plugins of the global course map, like it is static, obstacle, voxel, inflation layer, all these things. So that is the default value. So I am just changing this into this. So instead of inflation layer, we just use the gradient layer, which is this. Okay, which is our plugin. Okay, and in the local course map also, I can simply change this into this. Okay, and the gradient layer is also I have defined here. okay, the plugin that we have built. Now if we build it, gradient layer means it is showing, I mean the technique is mentioned in the tutorial. It is basically, we can see multiple gradient map. Maybe after seeing the output you can understand. So let it load. Starting the navigation. So now starting, okay. Now you can see the kind of map that we are getting. Okay. Okay, so if I'm just giving the goal position, one second. So are you seeing any differences? This is different, right? There are some color gradient happening. Okay, so the plugin is actually working. Okay, so this is gradient cost map. Okay, so we just change these settings. So I'm just changing the setting back to this. So simply comment it. So it's very easy to set up. Okay, that is the advantage. Okay, now we have the behavior tree plugin. So the behavior tree plugin is also using the same thing, same same structure. It is using a plugin lib structure, and so what is happening is that these behavior tree plugins, maybe I can show you that it is. So I just want to explain what is the behavior tree plugin actually. One second. Yeah, not behavior tree plugin. Okay, so yeah, so if you are creating a behavior tree, okay, if you are creating a behavior tree, behavior trees are like set of sequence, just understand like that. And so when the robot goes to this sequence, each node, okay, or each node or action or node in the behavior tree is executing something. Okay, it is doing some task. So you can create a custom node which is doing something. Okay, which is doing something. So here in this tutorial, what we are seeing is, we are seeing a behavior tree plugin in which we can use it for sending an SMS, I think. Yeah, I think it is. Yeah, it is just waiting. Yeah, it's a waiting plugin. Okay, it's simply just wait for, like, so what this plugin does is that it will be, when this plugin called, or if this node is called, it will be simply wait for 5 seconds or some duration. Okay, so there are different kinds of behavior tree nodes. There are decorator node, there are action nodes, there are sequence node. So I think in the behavior tree class we have discussed that. So you can create any behavior tree nodes. Okay, so in this example we are seeing an action node. Action node means it is executing something. Okay, executing something. So one second, let me take the behavior tree. Okay, I think the behavior tree example, yeah, I think it is not included here. Yeah, the only example that is there is the behavior plugin. Behavior plugin means the the recovery behavior. Okay, so the behavior tree example is not there, but maybe we can simply go through it. This is actually creating a behavior tree action plugin, and there is a format for that. It is not like the what the so-called plugin lib, but it is simply like a class, and we have to um, inherit from the BT action node. So actually what happening is that if you want to create a behavior tree action node, you have to inherit from it, and then you have to fill some functions. Okay, so that is what mainly it is doing. Okay, so there are different behavior tree plugins available. For reference, I am just giving the link here so you can have a look. So these are the plugins that is available for course map. Then this is the behavior tree navigator. So these plugins are for behavior tree node. So there is a BT node, right? BT node in the navigation stack. So these plugins are the BT navigation node, and these are for planners. So you will get lot of reference from here. Then these are different kinds of behaviors. Okay, so that is actually the I mean, yeah. So this is the behavior tree plugins. Okay, so like yeah, you can find list of plugins. So this is like wait action that is actually mentioned in the tutorial. So simply you can see this is actually inheriting from the BT action node class, and then there are some functions to override, like initialize, on tick means once it activate. Okay, once it like get a activation, it will be starting this function, I mean whatever. So basically when the this action go tick, it will be starting this initialize function, and in the initialization function there is a wait function. So this is the wait action class that we have seen in this tutorial. Okay, so I will suggest you to just go through it. Yeah, and in order to add that, after creating the behavior tree, you can just go to the first node, which is the BT navigator, and here the BT navigator is the node which is executing the behavior tree. Okay, so the BT navigator should load all the behavior tree nodes or the behavior tree plugins it is using. So each node is actually a plugin. So you can see here the BT navigator is loading all these plugins. Okay, so then only it can able to execute that behavior tree. It need these plugins. Okay, so I hope you got some idea about the plugins. Okay, so mainly I am giving importance to the planner plugin, which is what we need to commonly we need to work on, and other plugins are like other plugins I'm not sure like we will be using or not. Yes. Okay, so let me know if you have any question in this, and after clarifying this we can jump into the next set of plugins. Let me know if you have any question, guys, regarding the navigation plugins. Let me know any questions you have. I know it is taking, I mean it will take some time to learn things. So yeah.
So excuse me,
Yes, go on.
is there any example you want to provide about this one,
Yeah,
the
I mean,
behavior tree plugin?
yeah, these are the examples. Navigation to tutorial. I already shared. Maybe you can try this one. I already provide the link.
In inside there is a behavior tree, right?
Yeah, a behavior
Behavior
tree.
diagram.
For the behavior tree, um, there are some examples. I think. Okay, okay. There was one. I will share it because these are the plugins like that we can use it. This is actually the plugin. Okay, so maybe as a different project, let me just check. I have taken that, but let me see if there is a example. I will share it. Okay, I will share it. Okay, fine. Is there any other questions? Okay, so yeah. So again, we are yeah, I think it is already here. Behavior tree, yeah, which is talking about some yeah, we can just skip it. 1 second. Okay, so what we are going to do is we are jumping to the next set of plugins because it will be easy to understand the plugins, like almost all the plugins sharing a common template, so that's why it is easy to discuss it. So we have just gone through some important plugins development in the navigation stack 2. Now we have a set of plugins that we can do with RVs and RQT. Okay, RVs and RQT. So if you just take RVs 2, you can see a set of display type here, right? So what is a display type? A display type is simply a plugin. Okay, these if you just press add, you can find a list of display types. So these display types is actually a plugin. Okay, and what is the use of this plugin? This plugin is using to display something, visualizing something. Okay, so we will be seeing an example for the display plugin. Okay, and also there is another thing called panel in RVs. Okay, which is again like a panel which we can expand. For example, this is a panel for navigation 2. This is actually a panel. Okay, so we are going to see these example today. Okay, so how to create a panel in navigation and how to create a display type. So I will be explaining with some example that will be again easy. So first I will be doing is I will be demonstrating a display type. Okay, display type. So let me 1 second. Let me start some simulation that we have done yesterday. We have a camera. Yeah. So what I'm doing is I'm just starting a simulation. Okay. So what this simulation does is that it will be loading a depth camera. Let me see we are getting any topics or not. Yeah, it seems like we are getting some topics. Let me see that is working or not. Seems like it is not working. Or I can just try with some other example. So what I'm doing is I'm just starting some demos. Okay, some simulation demos. in which I can able to see an image. Okay, so after that I will explain. Okay, maybe the trigger camera. Okay, yeah, okay. So here what you are seeing is an image which is like from the gazebo. Okay, so basically if you check, the camera is here. Okay, and this simulation will be like I mean there is a camera plugin which is publishing the image, and we are starting the ROS gazebo bridge which will be publishing the ROS message, and RVC is visualizing it. Okay, so this is the normal camera display type. Okay, if you just check, you can see the image, then the camera. These things are by default in RVs. Okay, so what I did was I just added a new plugin. For example, it is called RV's rotatable image plugin. Okay, so this is one example that I have taken. So we can see what is this plugin does. Okay, 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 1 second. So yeah, so the thing is that 1 second. Okay. Yeah, so we have seen the same image here, right? And there is another option here. You can simply rotate this image. Okay, in this display type, in this plugin, there is no function there, but this plugin or this display type is having it. If I'm just giving the angle, the image can be rotated. I mean in the visualization. So if I'm giving any angle, it will be rotating like that. Okay, and if I'm just giving 3 degree, I mean if you give any degree, it will be working. Okay, so this is a plugin that someone developed. Okay, so this is a demo, and I just want to show you another demo for the panel. So if you just check, there is a panel. Again, it's a plugin, it's a package, and if I'm adding it, you can see a demo panel. Okay, so you can type here. I mean you can do anything with the panel, but this is just a demo. Okay, so these are the two things that we are going to see. Okay, so now going back to the example, we have ROS to control, and we have the RVS2 rotatable image plugin. Okay, this is a plugin that I'm talking about, and we have demo panel as well. Okay, so let's check it out what is inside the RVS2 rotatable image plugin. Okay, so this plugin, again, all the plugins shares the same thing. If you just check it, you can able to find the plugin lib. Okay, and you know, these RVs and RQT, it's actually developed using a framework called Qt. So Qt is a GUI framework which is extensively using in ROS. Okay, so the gazebo actually built using Qt framework. So Qt will give the windows. Okay, windows, widget, all these things Qt will give. So RVS is actually a Qt based application. Okay, and also RQT. So basically, if you want to build a widget or like any display type or the panel, basically we need the Qt libraries to build it. Okay, so you can see a set of Qt libraries. Okay, in order to execute it, and So that is in the package.xml, and in the plugin description you can see the same thing, like the name, then the name of the plugin, the the plugin and the base. Yeah, I mean the type is ROS2 displays image display 2. This is the name or the class name, I think. Okay, so this is the name of the plugin. Okay, and this plugin is inheriting from ROS common display. Okay, so so this is the plugin description, and if you just check the include folder, you can find the header file of the plugin. So in the header file you can find ROS2 namespace. Inside that there is a displays, again is namespace, and this is the class name, okay, called image display 2. Okay, that is what you are seeing here. One second, if you take the XML, you can find ROS2 displays image display 2. Okay, this is a class name. Okay, and you can find this class is inheriting from displays image transport displays. Okay, so basically it is inheriting from this class. Okay, and it will be getting some overriding function. Okay, and there are some other field. I will explain that. So if you check the include, you will get yeah, so these are some other functions that is mentioned in the plugin. That is not important. What we have to see is the so basically what happening is that one second. So this is a class called image transport display. Okay, image transport display, which is inheriting from ROS common this class. Okay, which is actually a part of display class. So what happening is that don't worry about this header file, just focus on this, and you can find the use of that class here. Maybe I can show. One second. Yeah, so 1 second. These are the overriding function that I mentioned about this plugin, like on initialize, then update. Update means whenever it is loaded, it will be start calling this function like an infinite while loop. Okay, and so this function, this class basically using in this, yeah, so you can see here this class is also initializing, okay, along with the plugin, and so I think it is somewhat complicated, like example I will say, but you can simply go through the function that we have to override. So this is the definition, the CPP file. You can find the constructor of this plugin. Then we have on initialize. Then we have the destructor. Here, and the main part of the plugin is update function. So this update function is constantly reading the image and then updating it. Okay, so I know it is not easy to understand because a lot of things are there, but just understand that um, the plugin ROS2 plugin, display type plugin, is having the same template. Okay, and you have to just fill it up, that overriding function. Okay, so let me see if I get some easy example compared to this. This is somewhat complicated, I will say. It is not that easy. Okay, but the concept is that, like, we are creating the plugin class, and then we are um, just what overriding the function. Okay, that is happening in all the plugins. Okay, so just have a look on to the demo panel, which is having the same structure. So if you just check, the base class here for the panel is ROS common panel, and this is the uh, demo panel class. And if you take the include, you can find the .h file. Inside that you can find demo panel class and inheriting from ROS common panel, and it is only having on initialize function. So let's see what is inside this. Yeah, so basically when you start it, it will be simply showing the text box and then the radio button. Okay, there is nothing happening inside this. Okay, so whenever we load this panel, it will be calling this initializer. Okay, this is a constructor basically. Okay, and it will be simply loading it, and you can actually not inherit, override this on initialize function, and also there are some more functions we need to override. We can do that. Okay, so I will be sharing this example. You can have a look. Okay, and let's see how it goes. Okay, yes. So I just want to show you RQT plugin as well. Okay, RQT plugin, again the similar stuff. So like if you just take RQT, what you are seeing is, I mean, this is the default. When you just take the RQT, you will get this plain window. Okay, there is nothing in it, but the RQT is actually a window that we can add plugins. You can see on the top, file, plugins, running, right? So we are basically loading the plugins. So there are list of plugins that is already there. You can simply load it and do the function. So I have a demo plugin called RQT tutorial CPP. So if I'm simply loading it, you can able to find it is simply creating a publisher and subscriber, and I can enable the publisher, disable the publisher, subscriber, and all. So I'm just enabling the publisher, so you can see here the publisher is publishing. So this is just a demo. Okay, and if I'm enabling the subscriber, you can see the subscriber just started. Okay, and if I'm disabling it, it is disabled. So just an example to show how the plugins work. Okay, so if you take all this example, you can see all these plugins are based on C++. Okay, using plugin lib, and you can see the same structure. So if you do the plugin.xml file, you can find it is the class name is RQT tutorial namespace, and RQT plugin is the class name, and the base class is RQT GUI plugin. Okay, so this is the base class which is using by RQT plugin class. Okay, and if you take one second, if you take the .h file from the include, this is for the plugin. Okay, so if you take the plugin class, you can see the RQT tutorial CPP and the class name is RQT plugin. And again, you have a list of functions to override. So you can see the virtual functions are need to be overridden. So init plugin, shutdown, save settings, restore settings, all these things we need to override. Okay, and so in order to demonstrate the publishing and subscribing, we have written another node, or not node, a class, which is yeah, it's actually a node which is inheriting from the RCLCPP node, and this is having the publisher and subscriber. Okay, so what is happening is that from inside the plugin class we have the node class here, I mean node object here, and whenever we press the button, okay, whenever we press the button, it will be invoking these functions. Okay, so these CPP file is having the definition of each functions for overriding, and there are some Qt related functions here. So how Qt work is that when we press the button, like you have seen 4 buttons to start, subscriber and publisher, right? So whenever a button is clicked, for example, whenever a button called pub on button, okay, so it is actually using a UI file, okay, in Qt. So you can see the UI here. So whenever we click this button is called pub on button. This is pub off, sub on, sub off. Okay, so in the code we can after creating a UI file like this, in the source code we can just say, we can parse this UI file, and you can say whenever we press the pub on button, it will be calling set pub on. Okay, set pub on means here. So it will be setting the some flags to start the publisher. Okay, then set pub off, set pub on. So basically when you press each button, these functions are calling, and simply just set the flags to start the publisher and the subscriber. Okay, so you can also try this. This is not that difficult example, and this is the node program. Node program basically means it is doing the publisher and subscriber. Okay, whenever we set the flag, it will be subscribing and publishing. Okay, so if you just go through all this example, what we understood was the Gazebo plugin, then Nav2 plugin, RQT, RVS plugin, there is a template. Okay, so don't worry about the technicality of each one. What you can do is you can work on each examples and develop an idea. Like I will say, what I am doing is I am actually setting an example, learning it how it is working, and then developing on the top of it. Okay, so that's how you can able to do this very easily. Okay, and I will be sharing all these links. So if you just RQT tutorial CPP, you can able to get this code. I will be sharing it anyway. Okay, so this is the example that I have tried, I guess. Yeah, so RQT tutorial, this is what I have tried. And for the panel, for RVS, I have used 1 second guys, I will be sharing the link. Okay, demo underscore panel. I will be sharing that. 1 second. Yeah, demo panel, this one. this is the example that I have taken for panel, and for image rotate plugin, I have used this one. Okay, so these are the example that I have used for this demonstration. Okay, so now I just want to ask, like, if you have any question, like immediate question in your mind, let me know. Otherwise we can just discuss these last topic. We have like 20 minutes. There is not much things to discuss in this topic because we already seen the same in ROS 1, so we can use the same. So I included this chapter like after discussing ROS 1 session. When we reach ROS 2, if there is any new improvement, like if new libraries are there, we will discuss, but it's almost the same. There is nothing changed. So let me know if you have any question, and after that I will take like 15 minutes 1 5, and I just want to conclude this chapter. And there is no I mean, these thing we already discussed. Okay, I think the topic we already discussed in the mastering session. So let me know if you have any question regarding the RWIS2 and RQT plugin. If you have any question, let me know. Otherwise, we can jump into right into the self-driving car concept. Okay. So I assume that you got some idea about it. Now is the time to discuss self-driving car. Okay. So I will give an introduction, and then we will be discussing the the list of packages or repositories that is available. Okay, so in ROS 1 we have seen how self-driving cars work, what are the sensors, and how to program it, okay, using ROS. So a self-driving car simply means like it is a full-fledged version of an autonomous robot, autonomous wheeled robot. Okay, basically a self-driving car, what is the functionality it is doing? We can enter to the car, we can give a destination, and the robot will be dropping you into that destination. So there are a lot of challenges, obviously. Personally speaking, I have seen the working of the Waymo self-driving car in San Francisco. So what they are doing is they have integrated the self-driving car technology into Uber and Lyft. Okay, so if you just book an Uber, then the self-driving car can pick you in the right destination and drop you in the right destination. Okay, so yeah, so successful companies in this domain is obviously the Waymo is like integrated to Uber, and you can ask for self-driving cars and it will come. Okay, it is work flawlessly. There is not much issues that I have seen in San Francisco. And yeah, so what are the technologies that we need to have on this robot? It's actually a robot car, right? So basically, if you check the image, you can find on the top there is a lidar, right? So if you take a wheeled robot or like mobile robot, there is a lidar for mapping and navigation. The same thing applicable to this. Okay, but when compared with a mobile robot, this is not that easy because it is going through a real road. Actually, there are pedestrians, cyclists, there are other vehicles, lot of things are going on. Okay, so this is actually the full-fledged version of a mini autonomous mobile robot, and the software blocks are the same. Okay, so if you just check the software diagram, uh, it is almost the same. Okay, I will okay, yeah, if you simply search it, you can find the architecture. I mean, there are multiple architecture, and which is having mostly similar thing. If you just check, I will take one second. Yeah, let me see this. Yeah, I think this will work. So here, what happening is that in most of the vehicles, one of the approach is that, I mean, the same thing, like we are mapping the place and then we are localizing it. Okay, so in case of San Francisco, what I am believing is that they have a good 3D map of San Francisco. Okay, inside the car they have a good 3D map. Okay, and using the set of sensors, we have camera, IMU, LiDAR, GPS, radar, odometer. Odometer means the odometer itself. Okay, we can able to localize on the map. Okay, then do the planning. Okay, so like once we localize on the map, then the user will be giving the destination. Okay, so then we will be creating a global plan and a local plan, same as the turtle board that we have seen. Okay, and then what will be the local planner does? The local planner will be creating the velocity commands, the control. It will be sending the control, I mean the control, the local planner will be generating the velocity command, and the controller will be controlling the steering and the steering and the acceleration. Okay, and you can do the same setting in the simulation like we have done in the turtle board. So if you imagine the self-driving car, you can also imagine the turtle board 3 or turtle board. It is doing the same thing but in a very complex manner. Complex manner means in a very robust manner. Okay, if the turtle board is moving through a small indoor road, uh, the autonomous robots are like equipped with very precise sensors, and it is having very good uh, localization mapping algorithm, control algorithm to do. Okay, so this is a software architecture, sorry. And there are set of project in the ROS environment for self-driving cars. So if you simply search for this, you can find lot of projects, from the basic project from like using turtle board to the advanced project. Sorry. So the problem is that only project that is working on ROS 2 is AutoWare. Okay, so this is only the project that I can able to demonstrate. I mean, demonstrate means just to share. But AutoWare is actually requiring lot of CPU, RAM and GPU. Okay, and also a map to demonstrate. So this is the main project in which you can able to find the documentation to set the AutoWare on the computer. But as I mentioned, you at least need a workstation to join it. Okay, to run it. So today I tried to run AutoWare on my PC, I mean using Docker. Maybe I can show you the instruction. Yeah, so this one. So these are the instructions I have tried. One second, guys. Yeah, this one. I'm not sure it is latest or not. Yeah, I think it is latest, like it is updated before 4 days. So you need to have a good GPU, then like 16 or 32 gigs of RAM and good CPU, and then uh, you can run the script to build the Docker and then run it. Okay. Unfortunately, I don't have that much of resource to do it, um, but the instructions are very straightforward. You can try it, and basically you can able to see the visualization and the mapping also, like mapping localization, if you provide a mapping file. Okay. So this is only the project that I can demonstrate, and it is also having some what some visualization like WebVis and Flow. That one second. WebVis is not actively maintained now, I guess. So this is actually for visualization of self-driving car thing, and it is now the Fox. Okay, Fox Cloud Studio. I think you may have heard about it. So this is actually the commercial product. So the WebVis turns to Foxglow, which is for a lot of visualization. Okay. So this is happening in the self-driving car domain. So if you are talking about ROS 2 specifically, we have mainly one project which is AutoWare. Okay. And I will say the AutoWare can able to simulate the robot. Okay. And there are set of simulators like Carla, which is one simulator that we are using for self-driving, and there is a simulator from Microsoft, and also the Isaac Sim we can use, and Carla is dedicated for self-driving, and there is a simulator from Microsoft. I can share that. It is I forgot the name. That's why one second, guys. Yeah, I forgot the name actually. Yeah, I think I got it. Yeah, AirSim. I think in ROS 1 I have shown to you this. It is also supporting the self-driving car project. So it seems like it is also not supporting properly. Okay, so only active simulator, one of the active simulator is Carla. Okay, so that is actually happening in the self-driving car industry, and I will say the self-driving car technology. I think before 3, 4, 5 years, there was a boom in this technology, and Apple was also working on this technology, but unfortunately, like Apple actually stopped this project. Apple stopped the self-driving car project because I think there are a lot of challenges in this domain. A lot of challenges because mainly it need a lot of years to improve. So the Waymo was the first company that was in the field, and they are active now, but again there are a lot of challenges. Okay, so Apple stopped this project. I think they poured millions billions of dollars into this project, and now they are, I think, focusing on AI. Okay, so they diverted the engineers to the AI project. Okay, so that is how it is going. Okay, self-driving car, these kind of project, they helped. I mean, these projects actually help the technology. I mean, these technology actually, like localization, mapping, all these things actually grew because of these funding and all. Okay, so there are a lot of research happen in this domain. So there are a lot of development as well, but I'm not sure when will this technology will be very common everywhere. In US, in some part, it is there, it is working good, but unfortunately, the problem is like if there is any accident happen, then there will be a restriction in this technology. So that's what I am seeing. Yeah. So regarding ROS 2 and self-driving, I will say there are very little, I mean, very small number of project. One of the active project is AutoWare. Okay. Yes. So the deep learning project, I think we already seen the same topics that I have mentioned. I think I have copy pasted it. So now what we left is this thing, which is becoming a ROS developer. So this is actually a general discussion, like what are the companies for ROS and robotics, and what are the universities. We will be seeing that tomorrow. Okay. So this will be helpful, like if you are looking for opportunities in academia and industry. Okay, so we will be seeing that tomorrow. Okay, so that's it, guys. Let me know if you have any question. We can uh, do the last session of the course tomorrow. Okay, so this is what yeah, so let me know if you have any question, guys. Any questions? I think today we actually discussed the main topics, which is the plugins and the self-driving car. We don't have any updates so far, meaning like there are no active projects, open source project especially. AutoWare is only project, and deep learning thing, it is a repetition, the same thing. And the last topic, which is becoming a ROS developer, we will be discussing tomorrow. It will not take much time, like 30 minutes or 45 minutes. Okay, so thanks for attending the session. See you tomorrow, guys. Thanks. Thanks, everyone.